Today, our essential question and our focus is on how do we use reference angles, but we're starting off with a quick review of a unit circle point and generating those 6 trig functions. Sine is our y value, cosine is our x value, and tangent is y divided by x or times the reciprocal. You can also remember tangent is sine over cosine. The 17s cancel, leaving us with negative 15/8. Those reciprocal functions, cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. A reference angle is a first quadrant angle that makes the same angle of rotation with the x-axis. Basically what it means is they have the same sine and cosine values, but in the first quadrant they're both positive. That's why I was telling you when we generated the unit circle, the first quadrant is the most important quadrant in the unit circle because it gives us all of the reference angles that we need to find values for other quadrants. We just need to think about, is the sign in that quadrant positive or negative? And by sine, I mean SIGN, not necessarily the sine SINE function. If your angle of rotation is given to you in radians, the reference angle is fairly straightforward. As long as it's one of those unit circle radians, pi over 6, pi over 4, or pi over 3, you simply drop the numerator to just pi. So thinking about the fact that 5 pi over 4 is in the third quadrant, its reference angle with the same sine and cosine values in the first quadrant would be pi over 4. We know that the sines in the third quadrant are both negative. Sine and cosine are both negative in the third quadrant, so our sine would be negative root 2 over 2. Cosine would be negative root 2 over 2. Tangent is the ratio sine over cosine. When you divide something by itself, you get 1. The reciprocal of sine would be negative 2 over root 2. Of course, we need to rationalize that. Remember, the shortcut is you move the radical up to the numerator and you drop the radical in the denominator. In this case, we can also simplify that 2 over 2 cancels, leaving us with negative 2. Of course, since sine and cosine are equal, cosecant and secant will also be equal, and cotangent, the reciprocal of 1, is 1. Negative 4 pi over 3. We'll worry about what quadrant that's in a minute, but the reference angle will be pi over 3. Again, you just drop that value in the numerator. At pi over 3, we have a coordinate of 1/2 root 3 over 2. Now to figure out which quadrant that negative 4 pi over 3 is in, we would have negative 1 pi over 3, negative 2 pi over 3, negative 3 pi over 3, and negative 4 pi over 3. In the second quadrant, our x value is negative, which is cosine, and our y value is still positive, which is our sine. Tangent will be sine divided by cosine, or times the reciprocal. The 2's cancel, leaving us with negative root 3. Cosecant is the reciprocal of sine, so we need to rationalize. Move the root 3 up to the numerator and drop it in the denominator, and the 2/3 doesn't simplify. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent, so we have that root 3 in the denominator. Rationalizing, move that up to the numerator and drop the radical in the denominator. Negative 9 pi over 2. The reference angle would be up here at pi over 2. We have 0, 1. We just need to figure out, would negative 9 pi over 2 be up there at 0, 1, or would it be down at 0, negative 1? So let's count. Make sure you're going in the negative direction. Negative 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5, 6, 7, 8, 9. We would be down at 0, negative 1. Our sine is the y value, cosine is the x value, Tangent is sine over cosine, but we all know division by 0 is undefined, so tangent is not defined at negative 9 pi over 2. Cosecant, the reciprocal of negative 1. Secant, the reciprocal of 0. You would end up flipping it, and 0 would be in the denominator, which would make it undefined. Now the reciprocal of undefined, if you think about flipping that 0 over negative 1, cotangent would end up being 0. And you have 2 U-Try questions today.